2. So we have two particles, P and Q, which are moving towards each other. So we draw them, P and Q, and we have our arrows going inwards in opposite directions along the same horizontal straight line. Particle P has mass m, and particle Q has mass km, so some multiple of m. The particles collide directly. Immediately before the collision, the speed of P is u, and the speed of Q is 2u. As a result of the collision, the direction of the motion of each particle is reversed. So our after has both P and Q going in opposite directions. The speed of each particle is halved. So if this has a speed of u, this will be a half u. This has a speed of 2u, this has a speed of u. Now we have to determine which direction we want to take as positive. So I'm going to pick right as positive. You can pick left. Your answers will be slightly different, but in the end, the methods will be slightly different, but the answers will be the same. So first up, we have to find the value of k. So we're going to use the principle of conservation of linear momentum. So the momentum before is equal to the momentum afterwards. So if we are picking right as positive, this u is going right, so it's positive. This 2u is going left, so it's negative. This is going left, so negative. This is going right, so positive. Get all your signs correct in the context of your global positive direction. So the momentum of P before will be m times u. The momentum of Q will be minus 2u times km, so minus k m u. I'll stick a 2 there. The momentum afterwards will be minus 2u, minus a half u times m, so minus a half mu. And the momentum of Q afterwards would be kmu. As with many of these, because P and Q are multiples of m, there is an m in every term, so you can divide by m. You will also notice that since the velocities are multiples of each other, you can divide everything by u as well. So dividing everything by mu gives you 1 minus 2k equals minus a half plus k. Adding 2k to the right-hand side gives you 3k. Adding a half gives you 3 over 2. Dividing by 3 will give you k equals 1 over 2, and that gives you the 4 marks. You can get method marks just for attempting this, even if you make errors. You can potentially get answer marks as long as you only make 1 error. But to get all 4 marks, you need to get the final answer as well. Moving on to part B. Find in terms of m and u only the magnitude of the impulse. So we know our impulse formula is mv minus mu. So we can choose, do we want to find the impulse of P on Q or the impulse of Q on P? Both of those are the same, so I'm going to pick P. So for P, our impulse will be, so the mass is m, the final velocity is minus a half u, minus the mass, m, and the initial velocity is u. So we have minus 3 mu over 2. And that will get you the second mark. If you got that, well done.